All right, so we are looking at this problem about Scott deciding to do push-ups as his daily exercise routine. And what Scott is doing is increasing the number of push-ups he completes each day. So here he did 3 push-ups. Here he did 5, 7, and then 9. So we can see that he is adding 2 push-ups every day. And so we know that a linear equation has a constant rate of change. That means they are adding the same amount every time. And so that constant rate, that ability to add the same thing every time, is you'll recognize it when you are on a graph. You would look at the slope and you would talk about going, if the rate of change was equal to 3, you would start at some point, and from that point you would go up 3 and over 1, and that would be your new point. You'd go up 3 and over 1, and that would be your new point. And so that is that constant rate of change. What were you doing every time? You were taking this point and you were adding 3. So when we're looking at Scott, we can see that every time we are adding 2, we are increasing the amount of push-ups by 2, and then we are moving over 1 day. So we can take this information and we can plug it into y equals mx plus b. So how many push-ups will Scott do on day n? Well, that n is just going to take the place of that x. So it's going to be y is equal to, well, what is he changing by every time? He's changing by 2. So it's going to be 2x plus b, if you remember, is the y-intercept. And that was when x was equal to 0. So it was 0 and then whatever y was. And so this would be the key phrase that we saw in our other examples at the beginning. But if you notice, the information they give us begins on day 1. So we need to back up and see how many he does on day 0. So what can I add 2 to and get to 3? Well, that is 1. So that means on day 0, he would have been able to do 1 push-up. So here is this written as a linear equation.